Hi everyone, this is Keshav Giri, application engineer for Mirabilis Design. And today we are going to be looking at how we can model Neoverse N2 CPU clusters using VisualSim Architect. So first off, going into the memory hierarchy, the structure from the Neoverse N2 configuration has been recreated in VisualSim in the following way. So we have the core clusters containing n number of processors, which is recreated using a dynamic instantiation block in VisualSim, which lets you configure the number of cores, and based on the input value that you provide, will instantiate that number of cores at the start of a simulation run. And for all these cores put together, we have a common data storage unit with a size of 64 megabytes. And for each core present in the core cluster, we have the MOP cache or the L0 cache, which is a 1536 entry 4-way cache. Then we have the L1 caches, the I cache and the D cache of size 32 kilobytes that also have 4-way associativity. And then we have the L2 cache, which is of size 1024 kilobytes and has 8-way associativity. And all these core clusters are connected to the data storage unit across a CPU bridge. Now, with regards to the cluster itself, it is fully configurable. You'll be able to configure the sizes individually for the I caches, D caches, L1 caches, and L2 caches. You can also specify which cores are the primary cores and which cores are redundant. You can define temporal cycles, the size of the DSU, the width of the DSU, the size of the L3 cache, and the cache speeds for all of the caches, the L1, L2, and L3. And we can also enable power consumption statistics for the core cluster. And with regards to the core itself, we'll be able to configure the processor pipeline. So we'll be able to set the clock speeds, the reordering buffer sizes, and configure the pipeline stages individually. We'll also be able to configure the number of execution units present in the processor. We'll be able to configure the load store instructions and which execution units are going to perform the load store instructions. And we can also set the execution unit buffer sizes. And with regards to the instruction set being carried out on this processor, we can add custom instructions to the instruction set. And we'll also be able to modify the execution latency for each instruction by providing either a fixed cycle delay or a range of cycles to enact the delay for the instruction completion. For inter-core communication between the cores in an N2 core cluster, the following approaches are used. So we have a shared memory. The producer cores will write the data to the shared memory pool, and the consumer target cores or the redundant cores will read from the same memory locations. The memory regions can be configured through the system address map. The task scheduling and the wake-up signals between cores are implemented using interprocessor interrupts. The interrupt sequences can be defined by using a task graph or by using events in visuals. Thank you.